David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Okay, our first unit was expansion and factoring. And this was a review of what should be prior knowledge for you in this course. So we're going to do this fairly quickly. Remember, there are videos for all these topics, and you can go back and drill over your old homeworks and things like that to master these techniques. And then just know, these techniques are all used in the next chapter and our last chapter. So expansion and factoring. Generally speaking, expansion is when you multiply things together to get a more consolidated result. Factoring is when you go the other way and you kind of unmultiply things to get a factored result. So these processes are the same, just different directions. So this is a standard FOIL problem. We'll go over that down here, product sum. I just multiply my first terms, my outsides, my insides, and my lasts, and I get this intermediate step right there with two like terms that I can combine, and that's going to give me this resulting quadratic expression. Okay? So expansion is that way. Factoring is that way. So if you expand a quadratic, you can undo that just by factoring it. So that gives you lots of nice ways to check your work if you have enough time on the test. Okay, so let's take a look at some examples. The most straightforward one was a simple greatest common factor. So greatest common factor would be looking at these expressions and realizing that there's a 6x in both of them, pulling that out and putting it here, and whatever's left goes in the parentheses. When you go the other way, expanding, that's called distributive property, and we would multiply the 6x on x to get x squared, and the 6x on the 4 to get 24x. So again, expansion, factoring. Difference of squares. This is a nice pattern. It's one of my favorites. A difference of squares is just, the reason it's called difference of squares is that here it is. That's a square, that's a square. Remember, perfect squares is what it's talking about. So the square root of 9 is 3. So that's a perfect square. And then the square root of x squared is just x. So another perfect square. So if you recognize that you have a difference of squares, then you can factor it by going x minus 3 and x plus 3. So that's the square root of that one, and that's the square root of that one. So it just has to have a minus and a plus, or plus and a minus. So difference of squares, expansion is that way, factoring is that way. Perfect square. This one was a little bit more challenging. What a perfect square is something times itself. Like 36 is a perfect square. Because it's 6 times 6 gets you 236. You can factor 36 as 6 squared. So the trick for this one is to recognize that if you're expanding, you've got x squared plus 6 squared, x squared plus 6 squared, and then you've got this middle term. And that middle term is always 2 times the x term and the constant. So this is 12x because it's 2 times x times 6, which gives me 12x. Going this way isn't so bad. If you don't recognize that it's a perfect square, you can FOIL it and you will get the correct result. However, going this way, it's a little harder to see that that's a perfect square, but it can be done. Product sum type, this is a FOIL. Just like this one up here, I gave you a different problem right there. So this is the binomial x minus 9 times the binomial x plus 3. And what we do is we do first, outside, inside, last. So that gets us x squared plus 3x minus 9x minus 27. We combine our middle terms. That leaves us with a minus 6x in the middle, and that's our expression. So that's expansion, went that way. Factoring comes the other way, and this is the more challenging question, but I've watched you guys do this in class, and I think you pretty much have it mastered. What you're doing is looking for two numbers that multiply to 27, a negative 27, that add up to negative 6. And that's negative 9 times positive 3. And so what that does is that gets you, when you're factoring, you don't even need to write this middle step because we know it's negative 9 and positive 3. So here we are back at this, x minus 9 times x plus 3. So that's how you factor a product sum type. When you expand it, you just FOIL it. Okay, the last one is splitting the middle term. This one gets a little confusing. I notice that students struggle with that, so let me see if I can help you with that. However, there is a video that explains the process, and you're going to get more detail and more support for that if you watch that video. So, splitting the middle term helps when you have a quadratic that has a value for a. It's not just x squared. So if you're factoring this quadratic, you can't FOIL it, or you can't product sum it. You have to kind of think a little bit harder about it. So I started this as an expansion problem, two binomials. So this is the factored version. We're going to come back and find that. If I FOIL this, I get these four terms, which then when I combine my middle terms, I wind up with 6x squared plus 5x plus 1. So expanding this is just a FOIL problem that I'm sure you guys feel comfortable and can do just fine. However, when you're going backwards, if you have one of these and they ask you to factor it, this is where it gets a little bit complicated. What you have to do, there's two things you need to find. You need to find two numbers that multiply to AC. So I'm going to find out my AC. That's 6. So I need two numbers that add up to my middle term that multiply to 6. So I've got that all sketched out for you. 2 times 3 is 6, and 2 plus 3 is 5. So if this were a factoring problem, starting here, I split my middle term, my 5x, into 3x plus 2x. So that's the split the middle term step. Everything else is the same, 6x squared plus 3x plus 2x plus 1. This expression is equivalent to that one. Then what you do is you have to look at the first two terms, pull out your GCF, so that there is a 3x in both of these. So I factored out my 3x. What's left here is my 1, and then these two terms. What's in both of those? You might say nothing, but there is something. There's a 1 in there. So that gives us our 2x plus 1. And that gives us our split the middle term factoring to go from this way to that way. I don't think we did too much splitting the middle term in this unit, but it is a technique that is there. Okay, the middle chapter in this unit was all about solving quadratic equations. So what we did, the fundamental addition we did to that process, is we set the quadratic equation equal to 0, and we solve for x. And as you know, that helps you find the x-intercepts, which is what we did in the last chapter. So we had several different forms. The most easy one was x squared equals some constant, such as, let's say we said x squared equals 64. Solve that one by taking the square root of both sides. You get x equals 8. Now what's wrong with that? Something I forgot. That's right. It's plus minus 8. Because negative 8 squared is also 64. This is a common mistake. People will forget the plus minus. And what happens is you lose one of your two solutions. And finally, remember that if you get a negative square root, if your answer is, if it's like x squared equals negative 64, you can't do that. We do have a way of handling negative square roots in mathematics, but you haven't been introduced to that yet. So this is no solution. And all that means is that this parabola doesn't cross the x-axis. That's all. It's a very valid parabola, just no x-intercepts. Okay, so let's take a look at this one. A little bit more complicated, still basically that form. We need to take the square root of both sides. So that would be x minus 3 equals plus minus 5. Square root of 25 is 5, but we have a plus minus. This is going to give us two equations now. We have x minus 3 equals 5, and we have x minus 3 equals negative 5. So for this one, we add 5 to both sides, and we get x equals 8. And for this one, we add 3 to both sides, and we get x equals negative 2. So this is a two-solution quadratic. Right here I kind of wandered a little bit, but it's all right there for you. Now this one is even a little bit more straightforward. We have this thing called the zero product law. What we have is two expressions. We have this times that equal to 0. So if this is 0, the 6x is 0, doesn't matter what x plus 2 is, the whole thing is 0. And if x plus 2 is 0, doesn't matter what 6x ends up being, the whole thing will be 0. So we have two little equations to solve. We have 6x equals 0, and that just gives us x equals 0. And then we have x plus 2 equals 0. which just gives us x equals -2. So this one also has two solutions. This one is a product sum type. So we need two numbers that multiply to -10 that add up to +3. And so those two numbers are going to be x plus 5 times x minus 2. Bring down my equal to 0. So just to check, 5 times -2 is 10, and 5 plus -2 is 3. So that's a correct factorization of this quadratic. Now I have two solutions. I have x plus 5 equals 0, so that gets me x equals -5, first solution. Second one is x minus 2 equals 0, so that gets me x equals 2. So those are the two solutions to this quadratic. Lastly, a split the middle term. I thought I'd do another one of those just to make sure it makes sense from the start. So I have a number for my a. It's not just a regular x squared. So I can't product sum factor this one. So what I do is I find my AC, that's 3 times -2, that equals -6. Now I need two numbers that multiply to -6 that add up to 1. So what would those numbers be? -2 times 3 equals -6. -2 plus 3 equals 1. Okay? So now I use those two numbers to split my middle term. 3x squared plus 3x minus x, minus 2x. Let's get that right, David. Minus 2x minus 2 equals 0. Now I have two groups of terms that I can factor a GCF out of. So 3x squared plus 3x, there's a 3x in both of those. It leaves me with x plus 1. Now there's a 2 in both of these. Let's take out a -2, so that it ends up being -2 times x plus 1. Since I took out a -2 from the -2, that went positive. And then with completing the square, we know we did it right if this term is the same as that term. And indeed it is. So now I just combine these two. 3x minus 2 equals, or times x plus 1 equals 0. Now I'm going to take this up here to finish it off. If this expression is 0, the whole thing is 0, or if this one is 0. So let's do those. 3x minus 2 equals 0. 3x equals 2. X equals 2/3. There's our first solution. Our second one is much easier. X plus 1 equals 0. X equals -1. Okay, two more techniques for solving quadratics. Completing the square and quadratic formula. So I'm going to do these real quick for you. Completing the square. Your first step here, if you remember, is to move the constant over to the other side. Okay? Now, what we need to do is we need to add b over 2 squared to both sides. So what's my b over 2 squared? My b is -4, so it's -4 over 2 squared. That's going to be -2. Squared is going to just be 4. So I have x squared minus 4x plus 4. Got to add it to both sides. So -2 plus 4 gives me a 2. Now this is a perfect square. And this just becomes x minus, for that minus, if that was a plus, this would be a plus, minus b over 2, which is just going to be 2, squared, equals 2. Now I can take the square root of both sides and get x minus 2 equals plus minus root 2. Add my 2 to both sides. X equals 2 plus minus root 2. So I have two solutions. I have 2 plus root 2 and 2 minus root 2. So remember, when we solve a quadratic, we're actually finding the intercepts. This one has 2 intercepts. Okay? So let's take a look at the quadratic formula. This one, if you look at it, it's not factorable. We could complete the square here. Actually, no, I take that back. We don't complete the square unless there's no a term, or it's 1. There's no extra number there. But this one has a is 4. So what we do is we use a quadratic formula. That's -b plus or minus the square root of b squared minus 4ac all over 2a. This is the value of x. So this is a plug-and-chug type problem. If you remember how I lessoned this before, I encourage you to do a complete plug-in check or step without doing any math, because I can give you good partial credit for that. So x is going to be negative 4 plus minus the square root of negative 4 squared minus 4 times a, which is 4, times c, which is negative 1, all over 2 times 4. So that step is complete plug-in. I didn't do any multiplication, addition, subtraction in my head. I just wrote it all out. So x is going to be 4 plus minus the square root. Now I have negative 4 squared is 16. And then I have 4 times 4 is 16 times negative 1. So I have two negatives there. So that becomes 16. Right? 4 times 4 is 6. Yeah, two negatives. So I don't need that much of a root sign. And this is all over 8. So I can simplify that down a little bit. This is going to be 4 plus minus root 32 over 8. Now, I'm not done yet. Root 32 is a good number to simplify. Just going to bring it down here. Equals 4 plus minus. Now let's take a look at 32. 32 is the same as 2 times 16. And 16 is a perfect square. So 16 comes out of the root sign and ends up as a 4. And my 2 is what's left. All over 8. Now this is going to reduce down. These go down to 1. And this would become a 2. So I have 1 plus minus root 2 over 2. That gives you your typical ugly answer, but that is the solution for that quadratic. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.